All right, here we go. So we are beginning with our first lesson of statistics in this unit, and we're going to be focusing on measures of center, right? So we're going to introduce statistics, we're going to find measures of center and try to figure out which one best describes the data. So let's start with a very beginning level definition of statistics, all right? So it is they are particular calculations from data. All right, so we are taking numerical data, we are collecting it, analyzing, interpreting, presenting it, and trying to gather significance from it is really what statistics is trying to get at. We'll just have a generic definition of particular calculations from data. So what is data? It begs the question. They are values along with their context. So much mathematics has to do with numbers, obviously, and they have nothing attached to them. They're just arbitrary numbers. But in data, as well as science, numbers have meaning. So all we mean by context is meaning, a label, a unit. Something like 12 could just be 12 in a math class, but in a science class, it might be 12 feet, or it might be 12 meters, or it might be 12 meters per second. And so that context is that label on the backside of the number to help us understand what it is. So in statistics, it's the same thing. 12 people, apples, dollars, what is it? Helps us understand that better. So there are two types of data that we are going to be dealing with. The first is known as categorical, and the second is quantitative. So categorical is just data that is organized into categories like color, ice cream flavors, more general things. It's not something that's necessarily being counted or measured, rather. They're categories of things that we are measuring. So quantitative is data that can be measured. Okay, so things like length, distance, height, etc. All right, I can actually need something to measure it against, and it's something that can have different measurements. You can have something that is longer distance or shorter distance or higher height, lower height, more mass, less mass, etc. All right. And so what we're going to do is we're going to figure out something called the center of data. Okay. And so a quick definition of that is really a single value that represents the center of a data set. So meaning that if there's one number to describe all the different data that we've collected, what would that number be? We call that the measure of center. Okay, and so there are three ways in particular that we're going to focus on. That is the mean, the median, and the mode. Okay, and so the mean is the sum of the values in a data set divided by the total number of values. A simpler way to remember that is just mean is the average. So when you hear these words, I want another word to pop in your head. So when you hear mean, we're thinking average. All right. And so the next one, that we are talking about is the median. Is the middle value of the mean of the two middle values when the data are arranged from least to greatest. That's important that it is least to greatest. So don't forget that. We'll talk about what's here in parentheses a little bit later, because we'll have a little bit more context to understand it. So again, with median, we want to think of the word middle. So what is the actual exact middle of the data set? That's why putting it in order from least to greatest is really, really important. Last is mode. Is the value that appears most often. So when I hear mode, I want to think of the word most. What value is represented the most? So if I had a list of 1, 2, 3, 4, 5, 5, 5, 5, 5, Well, 5 is listed a bunch of different times. That would be the mode of what it is. All right, so mean, median, and mode. All right, so let's try to apply some of this a little bit. So we have a race here of 8 finalists in the 100-yard dash. Okay, and so they have the race times listed. First step is always listing them in order from least to greatest. Okay, so Lance seems like he was the winner at 10.9 seconds. Okay, and then we got 11.0 shortly behind it. We have 11.2 and 11.3. Okay, then we have 11.7, 11.9, and 12.1 twice. Okay, so that's from least to greatest. All data points are represented. Now we need to find the mean. Okay, the mean demands that I add them all together. Okay, and so this is where having a calculator can be helpful. Okay, to do this a little bit faster than by hand. Okay. And that comes out to 92.2. And since there are 8 different runners, I will divide it by 8 because the mean, the average, is if I took all the values together, added them up, divided by the number of data points, in this case, number of racers, that would give me what all of them would have, and it would be the same value. And so in this case, it is 11.525 seconds, right? I want to make sure that I'm putting that label, that context in there as well. Okay. So now, the median. Okay, the median is the middle value. Well, I have an even number of data points. So if I count 1, 2, 3, 4, okay, then 1, 2, 3, 4, there is no data point right here in the middle. So what I do, and this is what these parentheses up here are telling me, that if I have an even number, what I do is I will add the 2 middle and divide by 2. Okay, so in this case, that would be 11.3 plus 11.7 divided by 2 gives me 11.5 seconds. So that is the median. Since there isn't one number, because I have an even number, I have to take the 2 center values, add those up, divide by 2 to kind of find their average to find the median. All right, then the mode, I just look and see which data point is represented the most. It is possible there is no mode if all the values are unique. But in this case, we have 2 that are 12.1 seconds, so the mode would be 12.1 seconds. All right. Now, part of what we're trying to do is figure out which best represents the center of this data. So we have to kind of look and think critically about whether the mean, median, or mode represents the center value the most. Now we have a little bit of guidance right here with these bullet points. The mean is typically most appropriate when there are no outliers, okay, an extreme data point. So in this case, we have these runners range from 10.9 to 12.1 seconds. An extreme data point would be something like 50 seconds. It's very different than the rest of them. That would be what we'd call an outlier. Okay, so if there are no outliers, then the mean can be a really good measurement of center. Now the median, similarly, no outliers and also no big gaps in the middle. We can take a look and see that there isn't a big difference between any of the data points, especially in the middle. And so that doesn't seem to be a problem. So for this data set, the median looks like it could be a good option. Okay. Or the mode is typically most appropriate when there are many repeated numbers in the data set, especially if it's more towards the middle. Okay, so that is a possibility. We don't have very many, just one that's repeated one time. So in this case, the mode is probably not the best option. So if I had to decide for either one or for this data point which number to use, you can look and see that the mean and median are both good options, and they are both very close to one another. And so there's reasonable, it would be reasonable to choose either one of those as the best center of the data. All right. So let's try another one here. All right. So first thing we got to do, list everything in order. So we got 42 Okay, then 49, then 49, 55, 60, 65, and then 77, and then lastly 145. Okay, so I need to find the mean, median, and mode of all these things. All right, so the mean. You got to add them all together. 42 plus 49 plus 49 plus 55 plus 60 plus 65 plus 77 plus 145. And I'm going to divide that by the total number of data points, which is 8. I'll end up with $67.75 is the average price. I look at the median. Again, I find the middle value. Median is middle, but it's an even number, so I got to take those middle two numbers of 60 and 55. So 55 plus 60 divided by 2 gives me $57.5. Okay. And then lastly, the mode. Which one is the most? 49 is the only value that is repeated. And so that would be $49. All right. So now determine which one is the best. Now this one isn't quite as clear as the others because there is some difference between all three values. There's not two that are really close to one another. And so what you can look at is these 3 bullet points to help you decide. Okay, but one of the challenges is there is an outlier. If you look at $145, that's twice as much as the next value to it. I would say that's an outlier. In further lessons, you're going to learn exactly how to determine if something is or is not an outlier mathematically. But for now, we're just going to be able to look and say, that seems really extreme. That looks like an outlier. And so I would say that's either the mean or median, but I'd probably lean towards the median being the best center of the data points. Okay, and so it is not the mode, since there's 2 data points that are on the lower end. It's not really towards the middle. We got an outlier way up top, so it's going to take the price a little bit higher because of that. The median can kind of account for that outlier a little bit, and so median would be the best option. All right. Now, last thing in this lesson, we're going to talk a little bit about what's called percentile. Okay, it's a measure that tells what percent of the data in a set are below a specific. All right, so that's important that it's below. All right, so percentiles measure rank from the bottom. All right, so you want to, I'll show you what that means exactly. So in this example, we have a list of cans collected by different homeroom teachers at Lincoln High School. So we are looking specifically at Miss Clark, so 151. So they arranged it in order from least to greatest, which is a good practice for pretty much all these problems. And so if I locate Miss Clark's homeroom is right here. If I need to pick out the percentile, okay, I need to look at the values before it. Okay, so a little kind of equation to help me figure this out, just to remember. Okay, figure this out by the number of data points less than the chosen variable divided by the total number of data points. All right, so let's apply it to help clarify. You take that value, multiply it by 100 since we're talking percentile. Okay, so let's take a look. We have them in order from 94 to 215. We found Miss Clark's at 151. And so I count the number of data points below it, not including the specific chosen variable, 151. So I see we got 1, 2, 3, 4, 5, 6. There are 6 below it. So that would be 6 divided by the total number of data points. Okay, so that's 6. So we got 7, 8, 9, 10 divided by 10 times 100 gives me the 60th percentile. Okay, and so Mrs. Clark's homeroom was at the 60th percentile. All right, so that's how we calculate percentile. We have a really good example right here. It'll give you some nice practice. All right. So, like all of these, putting them in order from least to greatest is going to be the most important part of this. And so let's list. All right, so we got 15, 18, 22, 24, 27, 28, 29, 30, 32, 36. Okay, so I got them in order. I'll change color here to help us distinguish a little bit. So we're looking at A, which is Atticus. All right, so Atticus' value right there is 28. Okay, so this is Atticus. So I need to count up how many before. I see 1, 2, 3, 4, 5. 5 divided by, all right, 6, 7, 8, 9, 10 divided by 10 times 100 gives me the 50th percentile. All right, so let's take a look at B. Oops. Take a look at B, which is Brett. So Brett is 32, so here's Brett. All right, and so I say 1, 2, 3, 4, 5, 6, 7, 8 beforehand. 8, there is a total of 10 times 100 gives me the 80th percentile. Okay. And you just continue this on, do the exact same thing for all the rest. And so I'll just go through and tell you the answers at this point. So C for Abram is going to be 60th percentile. Then D for Hazel will be the 20th percentile. E for Ainsley will be the 70th percentile. And F for Carrie would be, not Carrie, the 30th percentile. All right, and so that is all the notes for this. Okay, go back and check yourself. Make sure it's filled in and that you understand how to answer these questions on a scratch sheet of paper. And then I would say you have a pretty good understanding of mean, median, mode, centers of data, and percentiles. Thanks for listening.